In this lecture, we are going to give an basic overview about the deployment, the main deployment issue, what is the portability, and the portability is a problem that is strongly related with other life cycle stages of one of these big software projects. And we present Docker, that is Docker or another technology, containerization technology, as the solution in order to get fast deployment in our infrastructure, for example, Finisterre 2, but also in other infrastructures. As a starting point, I want to remark that currently in this project are involved several software with different requirements, and also several infrastructures like Finisterre, Plexi, and Sequana, all of them with different configurations, different hardware, different operating systems, and applications environment. If we focus in the software, particularly in the compilation stage, in this kind of projects involved in this project, we found several. Well, we can say that all of these projects, software projects, are really complex from the point of view of the software architecture, but also if we talk about the relationship of this software project with its dependencies, libraries, compilers, and configuration like environment variables and these kind of things. In order to perform the compilation of this kind of tools, they usually use build managers like AutoTools or CMake in order to perform and manage the whole building process that usually involves these steps like download, configure, build, test, and install the project itself in the infrastructure. That can be a personal computer or, in this case, an HPC cluster. These tools help to search dependencies and to resolve requirements in order to ease the compilation process while we try to do it in a new infrastructure through the feature of cross-platform compilation. Another stage involved in the life cycle of this application is the integration. That it means that when you try to move the software into a new machine and reproduce the build process, is strongly related with the previous slide about compilation, and it tries to perform this compilation in a new machine, ensuring that all is working properly. With the integration, in the integration step, we add the infrastructure variable, and in other, when we use continuous integration, we try to use several infrastructures, one or several infrastructures, and reproduce the integration step several times, usually per release or per commit or per tag, in several controlled environments. And what means controlled? But we cannot include all the possible infrastructures in a continuous integration process. We usually have several operating systems or several libraries versions of these kind of things. What is the main purpose of continuous integration? The early detection and fixing of the issues found while performing the integration stage, in order to avoid the integration hell. The integration hell refers to the process of building all the environment in order to have your application, your software project, running in a new machine. Usually, building the dependency matrix is a nightmare and related with several libraries or tools, and each one of these libraries and tools has its own life cycle and several versions, and not all of them works together, and it's really hard. In our experience, some installations that are supposed to be straightforward or easy, at the end takes weeks or months in order to have the application working properly in our infrastructure. Okay, when we talk about deployment, in the previous slide we talk about this new variable that it is the infrastructure, and in the deployment stage we fix this infrastructure in a production infrastructure, and when we deploy these tools, we try to reproduce again the integration process in these infrastructures, focusing in getting good performance results and have the software system ready to be used by the final user. Usually this process requires to satisfy the dependency matrix that from the point of view of HPC cluster means to install a complete hierarchy of libraries that must live together with other versions of libraries in the compute nodes. Usually needs to do custom fixing of the compilation process. Sometimes we also need to adapt the software, and depending on the version of the compilers and these kind of things. And at the end, underlying these slides, the same problem is always present, and the problem is portability. And when we mix several infrastructures with different kernels, different hardware configurations, different operating systems, different versions of libraries, and all these variables must work together in order to have your application running on the infrastructure. It is a big problem. These are the main points. But we experience these problems in the deployment stage, but from the other stage of the life cycle of the software, there is a big work in order to avoid the problem, but finally we will find it in the deployment. A good solution, the solution we find and we adopt for this project are the containers, well explained by Akos and Tamás. I cannot add anything more about talking about containers, only to remark that from the point of view of the final user, you feel, while using containers, you feel that you are in a different operating system, container system, and you have available all the requirements you need contained in this operating system and isolated from the rest of the applications installed in the host. Okay, I am going to avoid this slide. Okay, finally, which benefits we found from using containerization and related with portability. Well, not only related with portability. Like Tamás and Akos said, is a lightweight virtualization tool because you don't need to load a new kernel, you don't need to reserve the amount of space is going to be used by the container because the resources are directly shared with the host. The environment from inside within the container is secure and isolated. Like they say, the performance penalty does not exist. And another good points are the usage of containers empower users and developers. Users from the point of view of while you are inside a HPC cluster, you usually are a normal user. You cannot be super user. You cannot install anything using tools like YAM or apt-get or this kind of tools. And while using containers, you are able to deal with the system like as you were super user. And for the developers, they can decide how to deliver their software. They can decide which libraries go inside, which environment variables are defined and interact with your software, and give it directly to the users or HPC infrastructure ready to be used with minimal tuning from the HPC cluster. And this is why at the end the deployment of a container is as easy as to get the container, do a small step of bootstrapping the image in order to maybe install some dependencies required for the infrastructure, like InfiniBand libraries or these kind of things. And it's something that can be automatically performed, and the container is going to be ready to use.